Today, lesson 28A, we're going to go a little bit more in depth on the idea of a proportional relationship, and I've been throwing out hints in various lessons trying to tie those things in. But today, like yesterday where we went in depth with slope, today we go in depth with proportional relationships, including tables, graphs, equations, and trying to tie all of that stuff together. Okay, lots of background knowledge here. Proportional relationships are linear. We've talked about that in full detail in various lessons. They go through the origin, 0, 0. We've talked about that in many lessons. They have equations that are in the form y equals mx plus b, or excuse me, not plus b, but just y equals mx or y equals kx, where m and n are both just referring to the slope. The reason why there's no plus b there is because it's at the origin, which makes the y-intercept 0. And all the ratios of y over x are equivalent. Now yesterday, when we had tables and we were talking about slope, we had to find the ratios of the change in y over the change in x. And I don't want you to get this mixed up with that. Because what's happening here with a proportional relationship is that one of the ordered pairs is 0, 0. So if you found the change in y or the change in x, you basically would be looking at something like this. Some y number minus 0 over some x number minus 0, which leaves you with this ratio of y over x. But I don't want you to get this mixed up with what we talked about yesterday and finding the ratios of the ordered pairs within a table to find the slope. Okay, so that equation right there is an example of an equation that has a proportional relationship because it is in the form y equals mx or y equals kx, however you want to look at that. There are several others out of all those equations that are in the form of a proportional relationship. These are not written in your notes. What I want you to do right now is with your shoulder partner, I want you to find all of the other ones that have a proportional relationship. And I want you to write them down as you do them. In fact, off to the side of your notes right now, you could go ahead and write down y equals 4x, because that's one of them. All right? And then write down the other ones that you see. So I'm going to give you about a minute to a minute and a half to find all the other ones that have a proportional relationship. In y equals 4x, the 4 is the slope, but it's also called the constant of proportionality. And that was something you should have learned last year. So somebody give me another one that has a proportional relationship. Yes?
7x plus 4y equals 0.
Which one?
7x plus 4y equals 0.
Ah, okay. Why is that a proportional relationship?
Because if you subtract 4y from each side and then divide by 4, it comes out to be y equals 7/4 x, which is in the y.
Well, if you subtracted 4y, you'd have to divide by negative 4, right?
Oh,
So y equals...
by negative.
Yeah. But the point is that if you solve that, you're going to have something that looks like y equals kx or y equals mx, right? All right, so good. That one is. Yeah.
Y over 3 equals x is a proportional relationship.
Okay, how do you know that?
If you multiply both sides by 3, it becomes y equals 3.
Perfect. If you multiply both sides by 3, you have y equals 3x. That is a proportional relationship, and the constant of proportionality, or the slope, is 3. Camry.
Y over x equals 7 is a proportional relationship.
Why?
Because when x is multiplied to both sides, it becomes y equals 7x, which is...
And what's the constant of proportionality?
I'm sorry?
What is the constant of proportionality? So we can tell quickly who learned that last year and who didn't, right? But I have already mentioned it in the last couple of minutes. What's the constant of proportionality?
7.
It's 7. It's the slope. The slope, which we're going to find out today, is also the unit rate. It's also sometimes called the constant of proportionality because we have a proportional relationship there. Let's see here. We have 1, 2, 3, 4. I think there's one more up there. Brinthia?
Y equals 2/3 x.
And I don't think we even need to explain that one. It's already in that form. Brinthia, what is the constant of proportionality?
2/3.
It is 2/3. All right. So, once again, this one is This one is, wait a second, nobody gave me the y equals negative x yet, did they? All right. What's the constant of proportionality in y equals negative x? Negative 1, good. All right, so there actually were 6 of them. I was thinking there were 5. All right, so here, a lot of background knowledge from here on until we get towards the end of the lesson here. Here we have a table. In this table, it represents a proportional relationship. If you're asked to find the equation, much like an equation in slope-intercept form, we need the slope. We know the y-intercept is 0, and we know that the y-intercept is 0 is because I'm telling you right here that this table represents numbers that form a proportional relationship. So if we wanted to do that, we could graph if we wanted to. I accidentally went backwards there. Once again, I could graph if I wanted to. I could find the equation that way, or I could find all the ratios of y over x, and because it's a proportional relationship, I can get away with that. So all these ratios, and much like the warm-up problem today, you do need to check all of them. All of the ratios are 3.5. That's the constant of proportionality. All the ratios are equivalent, so my equation is y equals 3.5x. Or y equals 7 halves x if you wanted to write it as an improper fraction. Here's another problem where we're comparing cups of blue paint to cups of red paint. We could create a graph for that if we wanted to help find the equation. But we also could just check by finding the ratios of y over x, which happen to be 2/3 for all 3 of them. Since that is the constant of proportionality, and we know that this is a proportional relationship because it's linear and goes through the origin, that would make my equation y equals 2/3 x, and there it is, y equals 2/3 x. Okay, so I'm going to take this same problem here, and I'm going to change the variables. What if I, instead of using x and y, I now use r and b? How does that change my equation right here for this proportional relationship? Any ideas? Yeah.
Instead of it being y and x, it would be b and r.
Okay, well give me the equation though. That equation is y equals 2/3 x. What would the equation be with r and b in there? Yeah.
It would be b equals 2/3 r.
Okay. I'm going to change the letters again. If we used b and r, the ratios we're finding would be b over r, and that would make my equation b equals 2/3 r. How about if I change the variables to this? Q and a. Why q and a? Because I want to. Yes? There you go. A equals 2/3 q. And it doesn't really matter what I change them to. And notice that as I change them, that's not the only thing that's changing. What also is changing is I'm also changing the labels on my x and y axes here. So I can change them to whatever I want. I could change them to little b and little z, which of course would make the equation z equals 2/3 b. So we have to pay attention sometimes if the variables are different than just x and y. And like this problem. This graph represents 4 measurements of the amount of dirt excavated compared with the amount of time it took in hours. If we had a graph and we wanted to create a table, well, the table would be easy, and we don't necessarily need the table to create the equation. We could find the equation from the data right there. But if I wanted to do a table, I could, and all I'm doing is plotting or putting all the ordered pairs that are plotted into this table. So let me go ahead and find the constant of proportionality, and all I'm doing is I'm checking all of my d over h ratios. All right, could somebody please tell me what the equation for that situation is? Be very careful.
D equals 4h.
Yeah, when I asked somebody in first period, they went into automatic pilot and said y equals, we're not using y and x, we're using d and h. And so we know the constant of proportionality is 4, so it is d equals 4h. All right, let's continue with this review. This time I give you an equation. If you wanted to find a table from that, first of all, we know that this is a proportional relationship, so we know that 0, 0 is going to be in our table. We know that the graph is linear. And we know that the constant of proportionality is 3 because for about the 7th or 8th time today, the slope is the constant of proportionality. So I could just start with 0, 0. And once again, I start with 0, 0 because it is a proportional relationship. And then use my, I could just use y equals 3x and find all the rest. Or I could just use the idea of rise over run. That's why I zoomed in so I could show you. I'm rising 3, running 1. Using all of these ideas that we've already talked about in full detail. Plot a few more ordered pairs and fill in my table as I'm doing it. And so it would look something like that. And one of the things you should have talked about last year is how to quickly graph. The unit rate is essentially the slope. I'm not going to make you graph these things. But if I did, let's say that I asked you to graph this one. And you set up your axes right here. Which axis is this right here? It's not X. It's K. And this axis is D. So just make sure that you double check what's happening within your problem. Okay. Continuing on here, and I think at this point you've got some things you need to fill in here. Rate of change of a line is its slope. We talked about that yesterday. Rate of change is a form of unit rate. I hinted at that in the warm-up today. Therefore, the slope of a line is its unit rate. Slope is typically just a number. Unit rates must have units. So basically slope, we can get away with just writing a number like m equals 4. But if we're finding rate of change or a unit rate, because once again, a rate of change is a form of a unit rate, we must have units. Like in the warm-up today, I think it was $1.25 per, but I don't remember what it was per drink, $1.25 per drink. So make sure if you're asked for a rate of change or unit rate from here on out, we include the units for the problem. All right, so let me quickly, once again, compare the difference between proportional relationships and linear functions that are not proportional relationships. Proportional relationships are of the form y equals mx. And it's up to you what you want to write down from this list. Linear functions that are not proportional are in the form y equals mx plus b. Proportional relationships go through the origin. Linear functions that are not proportional do not go through the origin. And the reason why is because they have a y-intercept that is not 0. The slope is the unit rate in a proportional relationship. In a linear function that's not a proportional relationship, the slope is still the unit rate. Some of these things are in your notes, some of them are not. Proportional relationships, the ratios of y over x are equivalent. And as we found out yesterday, when we're talking about linear functions that are not proportional, ratios between all the ordered pairs are equivalent. And I've already explained today how those two things correlate with one another. All right, proportional relationships, and this is the last thing on this list, they have a constant of proportionality. But linear functions that are not proportional do not have a constant of proportionality. These two things have a lot in common, but there are a few things that are different about them. And I'm going to stop for about a minute to let everybody get caught up. Okay. Let's move on here. Here we have a problem. Phillip's car shop charges $25 per hour to fix a car. We are supposed to complete the table and graph, label the axes, write an equation that will represent the situation, and then figure out what the cost says. No, I guess we're asking, are the cost and time proportionally related? In other words, is this a proportional relationship? So I'll help you get started with the table, and then I'll let you kind of finish this problem off. At 0 hours, what is the cost? 0. So let's first of all go through and label our x-axis and our y-axis, or I guess I should rephrase that. Our c-axis and t-axis. That's what they really should be. So time is the t-axis and cost is the c-axis. $25 per hour at 0 hours, the cost is 0. Now, if we find the ratio there of c over t, that's undefined, so that doesn't help us. When we divide by 0, that is undefined. But we can go ahead and plot that ordered pair, 0, 0. At 1 hour, what is the cost? 25. What is the ratio of c over t now for that one? It's 25. It's 25 over 1, which is 25. And then we can plot that ordered pair, and I will let you finish this problem. All right, let's finish this table, finish the graph. For 2 hours, it's $50. The ratio is 50 over 2, which is 25. For 3 hours, it's $75. The ratio of 75 over 3 is 25. Plot the ordered pair, and we keep going here. And we connect them all together. So the question here, well, the first thing we're supposed to do is find the equation. Anybody have any idea what that equation would be? Make sure you use the right variables. C equals 25t. And we got the 25, and that's one of the reasons why we were doing our c over t's here. So the equation is c equals 25t. The second question is, are the cost and the time proportionally related? Another way of saying that is this a proportional relationship? Yes or no? Yes. Yes. The ratios of c over t are all equivalent. The graph is linear, and it goes through the origin. Everything matches up perfectly there. So I have a few more questions. Is there a constant of proportionality? Yes or no? Yes. What is it? 25. Constant proportionality is just a number. What is the slope? It's 25. What is the unit rate? It's not 25. $25 per. Yeah, the difference between unit rate and slope, while the constant part of it is the same, we need to make sure that we label the unit rate with units, the correct units in the context of the problem. Okay, everybody try. Number 5 all the way through, please. All right, 0 hours, and I'm labeling my t-axis and c-axis. Initial fee that should say fee, not feel. An initial fee of $40, and then $20 per hour. So technically, that would be $40 right there. That's undefined. That does not help us. And they have to pay $40 no matter what. So for 1 hour, it's going to be $60. There we go. 60 over 1 is 60. For 2 hours, it's going to be $80. 2 times 20, which is 40, plus 40, that's 80. And already, our ratios are not the same. And I'll keep going here. While this is a linear function, is it proportional? No, it doesn't go through the origin. That's one way of telling, but the other way of telling is this. These ratios, well, specifically right here, are not the same. So since those ratios of c over t are not the same, this is not proportional. But we can find the equation of that situation. So right now, turn to your shoulder partner and come up with the equation for that situation. It is a linear function, so we can come up with the equation. Equation for the situation here, what would it be?
C equals 20t plus 40.
Yeah, and that's not too much different than other word problems that we've dealt with before. Okay, so the only thing you need to do for homework tonight is to finish number 6 and 7. There's enough time left where you may be able to get through both of them. So number 6, I've already asked all these questions. Oh, wait a second. One more question on this one. we know the slope is 20. What's the unit rate in this one? I hear some of you whispering. What is it? $20 per hour. The slope is the unit rate with units. Just because it's not proportional doesn't mean that there isn't a slope or a unit rate. All right, here's what number 6 looks like. You'll need to, basically it's the same thing as the 2 previous problems. And then number 7, kind of the same idea. So go ahead and get those finished up for homework tonight.